Hello everyone, so today we're going over the second part of the unit over solubility charts. So your topic is solubility curves, and your topic is I can read and explain solubility charts. So the reason why I'm kind of using the both curves and charts is so they're kind of used interchangeably. Solubility curves are found on charts, so that way you just kind of have both that you can see. All right, so solubility curves. Here's different things you can see in a solubility curve or chart. The only one you need to write down is the second one, the one that's underlined. It shows the number of grams of solute that can be dissolved in 100 grams of water at certain temperatures. Now this is specifically 100 grams of water, just so it's the same for every compound. Now each line represents the maximum amount of that substance that can be dissolved at a given temperature, which we talked about yesterday. That would be a saturated solution where it has that maximum amount. Lines that show an increase in solubility, or the line goes up, tends to be a solid being dissolved in water, and lines that show a decrease tends to be a gas being dissolved in water. So here's an example of a solubility curve that you can see on this chart. On the side, you have your amount, your grams, how many grams you have in 100 grams of water, and then at the bottom you have temperature, which is in degrees Celsius, because to make math easier, Celsius is what we typically use in chemistry if we're not using Kelvin. So if it's at this line, this dotted line, that means it's saturated. If it's above the line, it's supersaturated. If it's below the line, it's unsaturated. So at any point above the line, it represents a supersaturated solution. So here, if we have 90 degrees Celsius and 50 grams, so if we match those two pieces of information, we notice it's above the line, which means it would be a supersaturated solution. Now, here's an example of a saturated solution. At 90 degrees Celsius and 40 grams, NaCl, if you match those up, it is right on the line. Since it is on that line, it would be a saturated solution. And then below, at any point below the line, is an unsaturated solution, which means it has less than the maximum. You can add more stuff to it without getting that maximum mark. So at 90 degrees Celsius and 30 grams of NaCl is right here. When we match those, it is under the line. And right here we can see it would actually need 10 more grams in order for it to be saturated. So since it's below, it would be unsaturated. So solubility curves, any solution can be made saturated, unsaturated, or supersaturated just by changing the temperature. So here is an example of a solubility chart. You notice there are tons of lines. Now here you have more than one lines. For each question, you will only focus on the compound it's talking about. So for instance, if you have a question talking about KNO3, you only look at the KNO3 line. All the other lines don't matter. It's just so you don't have to look at 20,000 different charts. It's all on one for you. All right, so in your digital notebook for solubility charts, here you have a solubility chart. The first questions: what mass of solute will dissolve in 100 milliliters of water at the following temperature? So number one is KNO3, which is this line right here. KNO3 at 50 degrees. So we go to 50 degrees. You will go up until you meet that line at KNO3, which is right here, which is 80 grams. So your answer would be 80 grams. That's how you do those first three questions. Okay, the following questions, the second part, write if it's saturated, unsaturated, or supersaturated. So here we have 60 grams of NH4Cl. NH4Cl is this line right here. It says 60 grams which is on the side. So 60 grams at 70 degrees. 60 grams at 70 degrees. Well, that's right on the line. So since it's right on the line, that would be saturated. If you did that and it was above the line, it would be supersaturated. And if it was below the line, it would be unsaturated. So based off what you have learned, you should be able to kind of think through the last two problems as well. If you have any questions about solubility charts or graphs or curves, let me know and I will be happy to help.